Let's begin our second unit in Chemistry 20 on gases. So, to begin, we know that there's some empirical properties of gases. Now remember, empirical properties are properties that are testable properties, and they are of gases. Now the ones that we're looking at pressure, temperature, volume, and chemical amount of gases. So we can measure the chemical amount by a mass. We can look at the volume by the amount of space a gas takes up. We can look at the temperature of that gas as well as the pressure of the gas on a container. Now, pressure is force per unit of area. So there has to be some sort of force, and there has to be an area containing that gas. Now, the standard imperial unit for pressure is pascals, all right? And in this unit, we actually use a unit called kilopascals. Now, again, 1 Pascal is equal to 1 Newton per meter squared. So standard atmospheric pressure at sea level is 101, and to be even more precise, it's 101.325 kilopascals. All right, so again, this pressure is a force per unit of area. Now, there's a variety of units of of pressure that we're going to take a look at now. And you will need to be familiar with all different units or types of pressure that we will talk about as we go through this unit. So first, I would like to discuss standard conditions. So essentially, initially, in a lab setting, we had what we called standard temperature and pressure conditions, or we identified that as STP. Now, STP, our initial pressure, was 101.325 kilopascals, or an atmospheric pressure. We also said that our standard temperature was 0 degrees Celsius, and we would have our temperature in kelvins, which we will talk about in a little bit here. Now, our standard temperature and pressure was hard to maintain because it's at 0 degrees Celsius. Not many lab conditions could maintain a 0 degrees Celsius, depending on where they were sort of around the world. So what we did is we came up with a thing called standard ambient temperature and pressure, or SATP, where the conditions are the same pressure at 101.325 kilopascals, or atmospheric pressure at sea level. All right, and then we decided to keep the temperature at 25 degrees Celsius. Okay, standard ambient meaning your surrounding area. Now, your surroundings usually are room temperature. This is a little bit warmer than room temperature, but we had a temperature that was a little bit easier to manage when dealing in a lab setting. Okay, now I put Dr. Freeze or whatever here on the side because, again, that would kind of be the lab setting that you would have to work in. You would always have to be quite cold if you were working at 0 degrees Celsius. So we adapted some of our settings. However, we do see both of these conditions being used in different lab settings or empirical settings just to see the different properties of gases. So if you see STP, know that we're at 0 degrees Celsius. If you're at SATP, you're at 25 degrees Celsius. The pressure difference really isn't too much. I think to be even more precise, at STP, our pressure is 100 kilopascals, where at SATP, it's at 101.325. But essentially those values, it's that 1.325 is so insignificant that we just maintain it consistently across the board. So our pressure units. Now, again, like I mentioned, sort of our standard imperial unit is a Pascal, and a Pascal is a Newton per meter squared. Okay, so again, like I mentioned, we deal with kilopascals. All right, so we're dealing with a bigger unit of our Pascal. Now, we also have an atmospheric unit, which is called an ATM. And an ATM is equivalent to 101.325 kilopascals. So 1 ATM is equal to our 101.325 kilopascals of pressure. Now we also can use millimeters of mercury. Now, essentially, millimeters of mercury was used to measure pressure, and it would be how many millimeters of mercury would be an actual scale in order to calculate the pressure. Now, 760 millimeters of mercury is equal to 1 atmospheric unit, or 101.325 kilopascals. And we've also simplified that and called it a torricelli. Now, 1 torr is equal to 1 millimeter of mercury. So if we look at all of our pressure conversions, we have that 1 atmospheric unit is equal to 101.325 kilopascals, which is equal to 760 millimeters of mercury, which is equal to 760 torrs. All right, so we have to be able to convert our pressures from any one of these units. In general, you will see these three appearing most often, so you should remember these three values and what they are equal to in order to do a unit conversion. All right, now I have this little joke here. It's 2 pieces of coal or carbon, and it says your dad's been under a lot of pressure lately, turning him into a diamond, which I thought was pretty funny. So another unit that we need to convert is actually our degrees Celsius. So we have a couple different temperature scales. We have our degrees Celsius, like I've mentioned, and we also have our kelvins. Okay, our kelvins is the more scientific temperature scale. Now that is because it's an absolute temperature scale. So essentially, absolute temperature scale is a wider sort of range of a temperature scale, and it was originated or formulated because we wanted to know what absolute zero was. So what what the scientists determined absolute zero was, it's the lowest possible temperature that we can record on Earth. And we determined that negative 273 degrees Celsius is the lowest possible temperature that we can get on Earth. And we called that absolute zero. Now, the thing that we need to understand with our 2 temperature scales is that they have equivalent degree rating. So what I mean by that is it's not like the Celsius to Fahrenheit scales where we have a variety of degrees in between each centigrade versus each Fahrenheit. With our Celsius to Kelvin, 1 degree Celsius is equal to 1 Kelvin. So every scale that we have is equal, each degree is equal to the other scale. So when we have absolute zero is equal to negative 273 degrees Celsius, where 0 degrees Celsius, if you look at the diagram on the right here, we see that 0 degrees Celsius is equal to 273 kelvins. If I have 100 degrees Celsius, it's 373 degrees kelvins. So what that means is if we have 100 divisions on our centigrade scale, we have 100 divisions that are completely identical on our Kelvin scale. And again, this was just to determine what absolute zero would be. So all temperatures should be measured in kelvins when we go forward with any sort of calculations involving gases. So in order to do that, if you have any sort of temperature in degrees Celsius, let's go with 25 degrees Celsius. If we add 273 kelvins, or the difference in our scales, okay, that's just the difference. If we add the difference, that equals 298 kelvins. All right, if I have 12 degrees Celsius, I add 273 kelvins. This gives me 285 kelvins. So all I have to do to convert my units from kelvins to centigrade or centigrade to kelvins would be either to subtract or add 273 from either value. Again, if I'm converting from kelvins to Celsius, I would like to subtract 273. If I'm going from Celsius to kelvins, I'm going to add 273. So you should be quite familiar with these conversions of both temperature and pressure as we go through the unit. Now, that's all I have for our introduction into our gas unit. Now, as we go through, you'll learn some more properties of gases, and Hopefully you'll be able to apply your knowledge of this temperature and pressure units to help you solve these problems. So, good luck!